students, today we discuss about gravitational potential energy. Now, what is gravitational potential energy? It means the gravitational potential energy of the body, the energy possessed by a body by virtue of its position above the surface of the earth, is called as gravitational potential energy of the body. So, it can be written as the energy possessed by a body by virtue of its position above the surface of the earth. So now we discuss expression for the gravitational potential energy. Okay, I can explain that. Now, consider a body of mass n. It is laying on a surface of the earth. Its mass is small n. Now, a minimum force is acting on the body to lift certain height in this way. Its height is small h. So here gravitational force is acting on the body in downward direction, but displacement acting on the body is in upward direction. So the displacement of the body is along upward direction, but gravitational force along downward direction. So here this height is very small with comparable to the radius of the earth. So here h is very small radius of the earth. We know that radius of the earth, that is r equal to 6400 kilometers. You know that. So now in this situation, gravitational force and displacement these are the two vectors. So its angle is 180 degrees because here these two vectors are anti-parallel. Now here these two vectors are anti-parallel, so therefore the angle between force and displacement, here displacement is equal to h, is 180 degrees because these are the anti-parallel vectors. Now the work done by the gravitational force is equal to F bar dot S bar. Here F is mg, here S is h cos theta. So this is the dot product of force and displacement. It gives work done. Okay. So now W equal to mgh So here angle is 180 degrees. We know that cos 180 is equal to minus 1. So minus 1 into mgh, that is the minus mgh. So now this work done is stored in the form of potential energy of the body at this position. So therefore this work done is equal to potential energy U equal to minus mgh. So this is the expression of the gravitational potential energy of the body. Next, we discuss about conservative forces and non-conservative forces. First of all, we discuss about conservative force. What are conservative forces? Conservative forces are the work done by the force around closed path is equal to 0. Is called as this force is called as conservative force. I can written as work done by the force around closed path is equal to 0. This force is only depends on point of locations but not depends on the path followed by the body. Okay, so conservative forces are mainly depends on point of locations but not depends on path followed by the body. So such forces are called as conservative force. So what are the examples of conservative force? Is gravitational force. Okay, spring force. These are the examples of the conservative force. I can explain gravitational, why gravitational force is a conservative force. Okay, so I can explain gravitational force is a conservative force. Now consider a body of mass m. It is a ball is projected vertically upwards in this way. Then the ball is rises. The work done by the gravitational force is negative in the case of upward direction. So here W1 is the work done by the gravitational force, that is W1 equal to minus mgh. Now the ball is returns to the journey of the to touch the earth surface. Its work done is positive. Its work done is positive because here gravitational force is along downward direction, displacement also downward direction. So therefore work done is positive. But in the first case, when the gravitational force is downward direction but displacement of the body is in upward direction, in the first case when a body is rises in upward direction, work done is negative. But in the second case, when the ball is descends, the work done by the gravitational force is positive. So W2 equal to plus mgh. Now the total work done around the total work done of the ball around the closed trip is W net equal to W1 plus W2. So we know that W1 equal to minus mgh and W2 equal to plus mgh. So therefore these are cancelled. So net work done around the closed path is equal to 0. So therefore gravitational force is a conservative force. Now we discuss about non-conservative force. What are non-conservative forces? It is defined as the work done by the closed path, the work done by the force around the closed path is not equal to 0, is called non-conservative force. In the case of non-conservative forces, is mainly depends on path followed by the force, path followed by the body. So here the non-conservative forces are mainly depends on path followed by the body, but not, it does not depends on point of locations. Okay, so we can written as its definition: the work done by the force around closed path is not equal to 0, not equal to 0. So such forces are called as non-conservative forces. Non-conservative forces are mainly depends on path followed by the body, but it is independent on point of locations. Okay. So what are the examples of non-conservative forces? So examples are frictional force and viscous force are the examples of the non-conservative forces. So why frictional force is non-conservative force? I can explain. Let us consider a body of mass m. It is laying on a rough horizontal surface. So this is the rough horizontal surface. Now, when a body is dragged along the rough horizontal surface from point A to point B, and then it's back to the point A. So in this situation, the work done by the frictional force is negative. So because the frictional force is acting on the body in opposite direction of the motion of the body. So here the work done by the frictional force from A to B is negative, because here frictional force is in opposite direction of the motion of the body, but displacement is in forward direction. So frictional force and displacement are in anti-parallel vectors. So the work done by the frictional force from point A to B is negative. At the same time, when a body is, it returns to the back in original position, that is point A, its work done also negative, because in this situation here when a body is moving from B to A, frictional force is in this direction, but motion of the body is in this direction. So here in the case of when a body is moving from B to A, frictional force and displacement are anti-parallel vectors, then the work done also negative. So therefore the work done by the frictional force B to A is also negative. So therefore total work done around the closed trip, that means A to B and B to A. It moves A to B first case. Second case, it moves B to A. So the total work done around closed trip by the frictional force is negative. So the total work done by the force around closed path is not equal to 0. Such forces are called as non-conservative force. So in this example, total work done around the closed trip is negative. So frictional force is a non-conservative force. Okay, thank you.